Yes. So today we will start the topic process. So what is a process? Okay. So better we start from this. So in day-to-day life, we can see various natural processes. Okay. I think. Wait. I will share my screen. Yeah. So you can see various processes. Okay. Suppose the room where you are sitting. So if you are using only fan, so your temperature will be different, your pressure will be different. Suppose in the same room, after some time when you will feel hot, so if you just use the AC, okay, air condition, then what will happen? So your temperature will change, okay, or your pressure will change. So that is another state. So in normal condition it is one state, in AC condition it is another state. Okay. So to reach the initial state, from the initial state to the final state, so the system, okay, so system will be your room. So system, the room will be changed, the properties of the room will be changed little by little. Okay, so temperature will little bit changed, then pressure will little bit changed, then again after 10 or 1 minute the pressure will little bit change, temperature will little bit change after 2 minutes. So gradually pressure will change, temperature will change, and finally you will reach a comfortable temperature. Okay, means number of intermediate thermodynamic equilibrium state you have reached, okay, your room has reached, and finally it comes to a comfortable equilibrium condition, okay, or comfortable state. So from one state to other state, that intermediate thermodynamic equilibrium, those states, when you will connect, then you will get a complete process. Okay, so from you can say from a hotter body, the heat goes to a cooler body, isn't it? So that is one process. Okay, so in between the transfer of heat, so there will be one process. Okay, so here in thermodynamics, so there are basically many processes are there. So basically we will start from this cyclic process. Okay, so what is a process? So it is a number of intermediate states which connects two states of a system, initial and final. So this is called as a process of a system. Okay, so first is a cyclic process. So cyclic process, what is a cyclic process? So cycle, okay, cyclic means what? So from which point you will start, again after traveling you will get the same point. So that is a cyclic. Okay, means the initial state, if the initial state of a system is equal to the final state, okay, or the properties of initial state and the final state of a system are equal, then the system is called as cyclic process. Okay, so in a cyclic process the system undergoes through a series of processes. Okay, so there may be numbers of processes, it may happen from one state and ends with the same initial state by forming a cycle. Okay, so that the properties of the system at the end of the cycle are the same at the beginning. Okay, just like this, suppose ice melts to water, okay, then water melts to vapor. Okay, then again if you just go in a reverse direction, then vapor turns to condense to water and water freezes to ice. Okay, again it will reach the same condition or same state. So that is a cyclic process. Or ice converts to water, then again in a controlled temperature or pressure condition, again you are getting ice from water. Okay, means from ice you have started, again you are reaching the ice state. So that is a cyclic process. Okay, so if you want to take the example of ice and water or ice, water and vapor, means to regain the original state, the properties should be the initial property, isn't it? The properties which was at the initial level, the final properties should also be the same as that of the initial level. So that is a thermodynamic cyclic process. Okay, so here you can see that I have told you that the state of a property can be defined by properties. Okay, and for some component, so we can define the state of a system by one property, for some system by two property. Okay, so here we are defining every state. Okay, the point 1 is one state, point 2 is one state, point 3 is one state, point 4 is one state, and in between 1 and 2 there are numbers of states. Okay, so we are not defining those intermediate points, but we are just taking this definite points 1 and 2. Okay, 3 and 4 distinct points. So we are just describing the system by taking two properties. Means two properties are enough to define the state of a system. That is why here one property maybe pressure, here one property it may be temperature or volume. Okay, so here property 1, property 2. So this state 1 can be defined by these two property. Let's say it is x-axis, let's say it is y-axis value. Okay, so this coordinate can be found out. Okay, so from 1 to 2, that is one process. From 2 to 3, that is another process. Okay, so this process is constant because this is parallel to this y-axis. Okay, or this vertical axis. So here whatever be the value at this point, so that value will be constant from 2 to 3. Okay, so from 3 to 4 another process, then 4 to 1, then another process. Means from 1 you have started and again you are reaching this point 1 after going through this all 4 processes. So this type of processes in thermodynamics, it is called as cyclic process. Okay, so here whatever be the property, you can see from the coordinate axis. So here let's say it is x1 and y1, then the initial properties will be x1 y1 and the final property is also x1 y1. Okay, so that is what it is said in cyclic process, that the process where the initial properties and the final properties are same. Okay, or initial state or final states are same, so that process is called as cyclic process. Okay, understood?
Yes, sir.
Yes, sir.
Yes, sir.
So yeah, so in the next slide here it is another process. Okay, so actually these are basic processes. Okay, these are basic processes which are occurring. Okay, which you can observe in our daily basis. Okay, then quasi-static process. So what is a quasi-static process? So a cyclic process may also be a quasi-static process, but what is a quasi-static process? We have to define in this way, that here you can see that property or state. Okay, the state A and B or these intermediate states can be defined by two properties, property 1 and property 2. Let's say it is pressure, it is volume. Okay, so by these two pressure and volume coordinate points, this process can be defined from A to B. Okay, so to define this process, so every point in between this point A and B, okay, so every point or every equilibrium points, okay, should be in thermal equilibrium. Okay, so every point in between this point A and B on this line should be in thermal equilibrium. Okay, so a quasi-static process is one in which the system deviates from the equilibrium state by only infinitesimal amount throughout the entire process. Okay, means all the intermediate points will be in a thermodynamic equilibrium state. Okay, so if you just join all these points, then you will get this line. Okay, so basically what is quasi-static process? So at the initial condition you will not get this line. So when changes happen from A to B, because arrow is given in this way, okay, from A to B, so all these points, intermediate points, whatever you will reach, okay, when the system will change from state A to state B, so all the intermediate points will be a thermal equilibrium point, okay. So finally when you will join all those thermal equilibrium points, so you will get this line or you will get this process, okay. And it is said that all these points does not deviate, okay, or if it deviates also, but it will deviate infinitesimally, means you can neglect, okay, the other effects and you can consider all these points to be in thermal equilibrium points. Means from A, if one, just like I told you that your room is cool, okay, your room is hot, let's say it is at 35 degrees centigrade. So now you are just switching on your AC, okay. So from A your room will cool, okay. So from A, let's say it will reach one point here, okay. So here the temperature, let's say earlier if it is 35, now it is 32, okay. So 32 degrees centigrade, and some proper pressure also you will get. So at 1 atmospheric pressure, let's say, okay. So now in the next 2 minutes or 3 minutes, again by the side of the point, second point, you will get a third point, so where your temperature will be 30 degree, okay. So that 30 degree will also be a equilibrium state, okay. So for some time it will exist, that is why the uniformity of 30 degree it will be maintained for some time. Then again after 2 minutes, let's say it is 28 degree, okay. Then again after some time, let's say it is 26 degree, then 24 degree, 22 degree, and finally you are obtaining 18 degree, okay. So from reaching 35 to 18 degree, so there are various equilibrium points, and when you will join all those equilibrium points, so you are getting this process, okay. And this type of process is called as quasi-static process, okay. So here in thermodynamics I told you that we will deal with the transfer of heat, okay, in thermodynamics in different for different processes by considering the system in equilibrium. So here you can see we are analyzing the process from state A to state B, so by imagining or by considering the equilibrium states in between these two A and B points, okay. So all the points in between point A and B, all the points which the system will reach in thermal equilibrium, okay. So in other words, a process closely approximating to a succession of equilibrium state, because this is a line which connects all the equilibrium points, okay. So that is why this type of process is called as quasi-static process. It is very, very important, okay. Quasi-static process. So you should remember this name, quasi-static process. Understood? Okay. So next, we will move to the next slide. Yeah. Then you can see the reversible process, okay. So let's say the system states, okay, let's say this is let's say the system is water, okay. Let's say the system is water. So in a suppose container, water is there, so system is water. The state of water, you can also imagine that the state of water, suppose it is liquid, so it can be defined by pressure and temperature, pressure and volume, okay. If it is contained in a particular volume, a particular container which is having some volume, then the volume V and the pressure P, so will be one property, okay, of the system. Let's say here it is P, capital P, and here it is capital V, okay. So in between these property coordinates, the states are defined. Let's say it is state A, okay. So from state A, the water is, let's say it is changing to some other temperature or changing to ice, let's say, okay. And from ice, again by using some process, so it is changing to water, okay. So this process is reversible process, okay. So what is a reversible process? A process is said to be reversible if the system passes through a continuous series of equilibrium states, because I have told you that the process will be equilibrium quasi-static process, means after going through number of equilibrium states it will reach point B, and after going through number of equilibrium states, the system will reach from B to A, means from water to ice, okay. So if it is converting from ice to water and water from ice, then number of thermal equilibrium points will be there in forward direction also and in backward direction also. Okay, then only you can connect these lines. Okay, so reversible processes can be denoted by these firm or distinct lines. But if one process is irreversible, if you cannot regain the original condition of the system, you cannot, okay, join by this continuous line, because the intermediate points will not be in thermal equilibrium condition. Okay, that is why you cannot join by a distinct or firm line. Then you will have to use some dotted line. Okay, some dotted line. So that is a irreversible process, but here it is a reversible process. Okay, one thing, see what is the concept behind this reversible process. So when you are changing one system, okay, suppose in a container water is there. So if you are just maintaining the temperature to 0 degrees centigrade, it will convert to ice. Means what is happening? Means you are just giving heat. Okay, means you are just releasing heat from the system. Where you are releasing heat? To the surrounding. Means when the water is converting to ice, the system is losing heat. Means system is changing from one state to other state. At the same time, the surrounding is also changing, because you are releasing heat from the container, isn't it? In fridge, what happens? So by the side of the fridge, you can just feel heat, isn't it? Refrigerator. So by the side of the refrigerator, back side of the refrigerator, you can feel some heat, isn't it? Why? Because the system is releasing heat. That is why your inner side is cooler, okay, and outer side is hotter. Means your system is also changing, your surrounding is also changing. So this is the forward process. Now if it is a reversible process, then what will happen? The system will again hot. Okay, means the water will again convert to ice. Okay, means the system will again regain its original position and the surrounding will again regain its original condition. Means in reversible process, the system and surrounding does not loses its property. All the properties will remain. It is whatever it was there in the initial condition. Okay, so there will not be any change in the properties. So then only it will be a reversible process. I don't know whether you have understood or not, but I think it will be clear to you. Okay, short means after 2 or 3 lecture, because we will again take this reversible process. Okay, so that is a reversible process, and it can be shown by distinct or firm lines. Okay, by joining this A and B, so we can just draw these lines. Okay, next is irreversible process. I have told you that from A to B, okay, so it is the forward path. Means let's say from water, so water is converted to ice. So water is the system, so that system is converted to ice at point B. But and in this process, what is happening? The system is changing. Okay, the system is losing some heat, because when a hotter system will lose some heat, then only it will cool. Okay, and it will finally cool to ice. Okay, so now if you just want to convert that water to ice, but it is not happening. Why it is not happening? Because it is not reaching some equilibrium state. Okay, so that process is not a reversible process. Actually, sorry, this process you cannot take. Okay, this conversion of ice to water, this process you cannot take, because conversion of ice to water, it is possible. Okay, and water to ice is also possible. That is reversible process. But here, so there are some processes. Okay, the natural processes, actually those are irreversible processes. Okay, so in controlled way, ice is converting to water, water is converted to ice. That is a reversible process. But in nature, okay, so it is not possible. Okay, that is why all the natural processes are irreversible processes. Water falls from higher elevation to lower elevation. Okay, so naturally water doesn't go from lower elevation to higher elevation. Okay, so heat flows from a hotter body to a cooler body. It doesn't flow from a cooler body to hotter body. But if you apply some external agency or external media, then it is possible. Okay, forcefully it is possible, but naturally it is not possible. That is why all the natural processes are irreversible process. So it cannot reach thermodynamic equilibrium state in the reverse way. Okay, So that is in the backward direction, it cannot attain the same position. If it is A, it will be A dash. It is not A, okay? It is A dash. Okay, that is why this process is irreversible process. And I told you that irreversible processes are denoted by these dotted lines. Okay, you cannot join all these points because those intermediate points are not in thermal equilibrium. Those intermediate points will be in non-equilibrium states. Okay, that is why these are dotted line. Okay, so you need to remember this. Okay, so till now whatever process, cyclic process, reversible process, irreversible process you have got, these are the basic processes. Okay, these are the basic things of thermodynamics. Okay, so in broad sense, okay, so if you want to just categorize these thermodynamic processes, then these processes are, some of the processes are isobaric process, isothermal process, isochoric process, then isentropic process. Okay, so these are actually the processes, actual processes. Okay, and those three processes are the basic processes. Okay, whatever we have covered till now, means in all these processes, means isobaric, isothermal, isochoric, isentropic. So we will come to these points later. So all these processes, so you will see those things whatever we have studied till now, the cyclic, then reversible, then irreversible. Okay, so basically means in thermodynamics, basically these are the application processes. Okay, and those three processes, cyclic, reversible, irreversible, those are the basis of all these processes. Okay, so these are application processes, okay, or the applied processes of thermodynamics. So what is a process? So change from one equilibrium state to another, it is called as process. Or intermediate, change of states from one state to another, which is composed of number of intermediate thermal equilibrium states, that is called as, when you are joining those two processes, that is called as process. Okay, states, when you are joining the two states, that is called as process. Okay, then what is isobaric process? So in isobaric process, so pressure will be bar. Okay, bar is what? Bar is the unit of pressure. So isobaric. Okay, so pressure will be same. So pressure will be constant. So for a particular system, if you are changing the system, okay, by giving some external agency, so if your pressure remain constant, okay, suppose in one container, okay, at one bar or at one atmospheric pressure, some gas is there. Okay, suppose in a piston cylinder arrangement, one little bit gas is there confined in that piston cylinder, gas is there. So that gas is exerting some pressure. Okay, so if you want to increase the temperature, okay, without changing the pressure, then that process will be called as isobaric process. Okay, so pressure will remain constant throughout the process. So okay, then isothermal process. So in isothermal process, thermal, okay, therm means temperature will remain constant. Okay, so here property held constant will be property. Then isochoric process, the volume will remain constant throughout the process. Suppose the system is changing from state 1 to state 2, the volume will not change. Okay, so you can take the example of the same piston cylinder where some gas is there. Okay, so if you just burn, okay, so what will happen? Temperature will increase, but the piston will not move. Okay, that confined space will be remain the same as that of the initial condition. Means volume is constant. Okay, the gas is not expanding nor it is contracting. Okay, so that is a isochoric process. Okay, temperature may change, pressure may change, but volume will be remain constant. Then isentropic process. So here entropy. So what is entropy? Actually, entropy is the randomness of the molecule. Suppose you are hitting some system, so that your molecule will attain some kinetic energy. Okay, and due to this kinetic energy, the internal temperature of the system will increase. Okay, because of the collision of the molecule. So that is called as entropy. Okay, and if you can make the system, the entropy of the system constant, so that process will be called as isentropic process. So for this timing, you need to remember only this term. Okay, so we will come to all these topics, okay, in an elaborate way. In few lectures. Okay, so you need to remember that processes are isobaric, isothermal, isochoric, isentropic. So I have defined those later on. So I have told you isobaric process. So suppose the states of the system. Okay, suppose it is water, the system is water, the states of water is defined here by P and V. Okay, so pressure and volume, because these are the property, okay, of the system: pressure, volume, temperature, okay, these are enthalpy, entropy, these are the properties of the system. So here in this axis, this is V1 and this is V2 or Vi, initial volume and final volume. Means system is expanding, volume is changing. But here you can say that from this point to this point, okay, so when the system is changed from this point to this point, the volume is constant, means isobaric process. Here from this point to this point, this process is isobaric process, as because in isobaric process the volume is constant. And from here to here, okay, so when the system will move from state this to this, the pressure is constant. Okay, so here the volume is increasing, means the system is expanding. Okay, but the pressure is constant. So that is why Pi equals to Pf. Initial pressure equals to final pressure. That is equals to the pressure P. Okay. Again, from here to here, what is happening? Volume is constant. Okay, but pressure is decreasing. So here pressure is decreasing, changing, but volume is remain constant. So this is also isobaric process. Okay. So from here to here isobaric, from here to here isobaric, and from this point to this point it is again isobaric process. Volume means constant. Okay, so here it is isobaric. Bar means del P equals to 0 means P equals to constant. Okay, so differentiation of P equals to 0, P equals to constant. So isobaric. So here you can take the example. This is cylinder. You can imagine in 2D. So in 3D it will be a cylindrical container. Okay, so this is cylinder, the outer part, and in inner side it is piston. Okay, just like a syringe, medical purpose use syringe. Okay, so this is cylinder, this is piston. So here gas is confined. So the volume, okay, the volume is constant, but you are heating this. Here it is heating. Okay, so before heating this is the volume, after heating when you will just burn the flame, okay, so the volume is not changing, the piston is not moving upward. Okay, the gas is restricted by this piston. Otherwise, if there is no restriction, so what will happen when it is hot? So the gas will try to exert some pressure on the wall of the, on the surface of the piston, and it will try to move upward. The piston will try to move upward, but you are giving some weight or giving some external force, okay, to fix the piston. So then volume is not changing, but temperature is changing, pressure is changing. That is why volume is constant. So this process is isobaric process, okay, or isometric process here, but don't write isometric, only isobaric process. Okay, so in between P and V, so from here to here, if this is one process, so volume will be constant. So by this line, you can see that volume is constant. And isothermal. So in between T and V, if you are just defining the state of a system by temperature and volume, so T is constant. Okay, so here you can see this is horizontal, means T is constant for this process. Okay, so again it is written same thing. So these are the other types of processes. So we will come to all these processes. Okay, so isentropic process you have got. Entropy is adiabatic process, means there will not be any change of heat in between the system and the surrounding. The boundary of the system is insulated. Okay, but temperature may change inside the system. Okay, but there will not be any transfer of heat from the system to the surrounding or from surrounding the system. So that type of system is called as adiabatic. So we will come to these all 3 points later. Okay, so till today, so whatever I have just told you, okay, in this lecture, so you just go through this lecture. I will upload these slides in the not slides, this video lecture in the Google Classroom or in our YouTube channel. So just you go through it. Okay, and if you find out any difficulty, just you can send your doubts or post your doubts in the comment box. Okay, below the video lecture where I will be uploading in Google Classroom. Okay, so yes, any doubt, dear students? Any doubt? Arkisman, Rishikesh, Partha, Rehan, Emiel, Teja, Nosal.
No, sir.
Okay, okay. Yeah, in the comment section I can see your comment. So see, just because this is a new subject to you, no? So just you go through those lectures, okay? Whatever I shared, the NPTEL lectures and my video lectures, okay? And you just take one reference book, okay, and you go through it, and whatever difficulty you is fine, so you can ask me, okay? By phone also you can call me, no problem, okay? So in the break time also you can call me, in the evening time also you can call me, no problem, okay? Or you can post the doubts in the comment section, okay? So thank you dear students. I have recorded the attendance also. So okay, have a nice day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.